This is a concept computer case I built, and it's the latest prototype as I iterate towards my next major case design. I've been working on this series alone, but if you've been watching our channel for long enough, you'll remember when my wife was more involved in the projects. Lately, she's been focusing on something much more important than anything I've ever built out here in the shop, and I wanted to show her how much I appreciate everything she's done for our small family. So I'm gonna make her something that any new mom would want. You guessed it. A totally custom small form factor PC with 3D printed chassis, dual integrated radiators, resin printed water cooling, meticulous cable management, and an overall case layout that's never been tried before.
That actually sounds pretty cool.
If this is going to be an improvement over the last case, then I need to get more ambitious with the design. So here are 4 new features that I need to satisfy. Number 1, it has to be a fully functional PC. Judy Ann would appreciate something she can actually use, unlike the last case, which was missing a lot of hardware. The main purpose for that build was to investigate the resin printed components, which seem to be holding up just fine. But there's no better test than making the real thing and seeing how parts behave with actual temperature cycling. Number 2, integrated radiators. We are no longer going to have to rely on an external unit. And to make this even more difficult, I'm keeping the same 20-liter volume constraint as last time. Number 3, ease of maintenance. Everything inside the case needs to be fully accessible without any major disassembly or draining of the cooling loop. It also means adding a proper drain and a fill port, so we can quickly replace the cooling fluid when the time comes for that. Number 4, better airflow inside of the case. Components like the VRMs and the chipset on the motherboard still need air cooling, and I plan to handle that with a single case fan on the previous design. We can do better than that. The first thing I need to do is figure out the radiator placement. I wanted to keep these outside of the case similar to my wall-mounted PC. So here are my first thoughts. But if I flip my old layout forward, and I add my radiators here at the back? It gets kind of large, but I can shrink the main enclosed part of the case if I take the power supply out and place it back here. This still leaves plenty of room for the radiator exhaust, and I bet it's going to make cable management much easier. But I can already see some issues with this. If I put the case in a corner, it'll trap a lot of heat behind it. And I don't want Judy Ann to have to flip this thing on its side every time she needs to access the ports. But what about this? This setup takes advantage of natural convection, drawing cool air in from the bottom and pushing the hot air out the top. And it also reminds me of this roof shape I used to see when I was growing up. It's called the Robertson ventilator, and it was a popular feature for glass factories that need to vent large amounts of hot air without letting in rainwater. When I first get an idea like this, I actually start out working in Blender, which is the same program I use for all of the animations in this video. And the reason I do that is it's really great for concept work. I can pull in all of my main components and then just start playing with shapes and layouts in a modeling environment that's really flexible and forgiving. This is the same thing I do professionally as well. I find that if I start out in Blender, I can be several iterations into a project in the same amount of time that it would take me to make my first iteration in CAD. And then I have the added benefit of being able to share renders and animations with coworkers and clients, so I can get direct feedback before I've invested a lot of time in the details. So here we are, 19 different versions of Judy Ann's computer before I arrived at something I was ready to model in CAD. One of these made it into a Patreon post. Thank you to our early members over there. That's the best way to get updates on our projects in real time. Alright, so it's been a couple weeks and I've been able to flesh out most of the details for this case design in Onshape. Let me give you a quick tour of some of the features. It's all going to start with this 3D printed chassis. We have a mini ITX motherboard on one side and our GPU over here on the other. Up top we'll have an SFX power supply, and we'll use some clean cable management to connect everything down to our components. We've got our 2 radiators, and these are going to feed into a front panel distro plate that'll house a flow indicator, pump, fill port, drain port, and a couple temperature probes to measure both the hot and the cool side of our loop. These will report back to an Aqua Computer Quadro, which will use the data to drive the radiator fan speeds. Connecting the CPU and the GPU over to the distro plate will have some resin printed tubing, and we're also going to use resin for several other components that I'll get more into as we start building. For airflow inside of the case, we'll have 3 case fans here at the bottom. The air will rise through the case and exit up here at the top between the 2 radiators. Both side panels are going to be removable without draining the loop. The We'll just have to put the case on its side and remove 4 screws to gain access. And then finally, we have a cover up top, and I wanted that to almost look like an architectural detail. That's what Julianne studied in college, so hopefully she'll approve. The full build comes in at 19 liters in volume, and that includes all of the space up here at the top as well. Alright, let's get started with the case chassis. This is a big part, and it's going to use up most of the volume on my H2S. It's a 16-hour print, and I'm using PETG for the filament, but unfortunately, I'm not seeing the results I wanted on this first swing. These features are wobbling during the print, and that's creating some ugly ridges. We'll need to improve the design, so I'm going to add a lattice structure here at the bottom that won't restrict our case airflow, but it'll help unify our parts together into a stiffer shape. And that also ties into this center spine of the chassis. I'm going to be reusing some older components for this build, partly because I had them left over from a previous project, but also because this case is taking some risks and it's still a bit of a prototype. But everything used will be detailed in the description below. I'm removing this backplate so I can install the specific one that's going to work with our eventual CPU water block. And then we have our standoffs that we're going to use to mount the motherboard. This is a dual reverse riser cable for connecting our GPU to the motherboard. This is going to allow us to mount the components back to back in what's called the sandwich layout. This is a NVIDIA 2080 Ti, which is several generations behind the latest graphics card, but it's still going to be a great test for our water loop. And it has plenty of power for what Julianne needs from her computer. I'm going to get started on the distribution plate, and first I need to laser cut my cast acrylic. I have another video that goes into more detail, and you should check that out if you want to see the whole process coming up with this technique. These feet are going to help lift the case up off the desk, so there's plenty of clearance for the case fans. And on top of them, I have this part that will mount our LED strips. It has one continuous slot routed through it, so I can just insert the whole strip without any cutting or soldering. These are some TPU forms that are going to help us cast a silicone seal in place between our 3 acrylic plates. And then I'm just tapping these for my eventual temperature probes. Now for some cable management. I was inspired by this solution by MXC Builds, so I decided to try something similar. He's got some really awesome case designs if you're looking for another channel to subscribe to, after, you finish subscribing to this one. This is my second video exploring resin printed water cooling components, but today we're going to be taking it a little bit further. This part is going to replace the front cover for our CPU water block, so it'll be in direct contact with the copper cold plate. I'm using clear resin V5 from Formlabs, and it has a published heat deflection temperature of 74 degrees Celsius when properly post-cured. The water in this loop won't get anywhere near that unless we have some sort of pump failure, but I have a solution for that as well, and we'll get into that in a little bit. In order to remove my support marks, I'm going to wet sand these all the way up to 3000 grit sandpaper. The end result is still a little cloudy, but I'm going to brush on a light coat of fresh resin before we do a final longer cure at 60 degrees Celsius. And this made a huge difference. I'm going to reuse these tiny seals from the original acetal part that came mounted to our GPU block. And I've incorporated these grooves directly into my resin printed tubing, which is going to help me save a lot of space. Before I install these radiators, I'm going to flush some distilled water through them to clear out any gunk left over from the manufacturing process. But I also wanted to take this opportunity to do some simple testing for leaks before I go any further with the build. Once I have these wires trimmed to the perfect length, I've got a little shelf here that'll help hide them out of sight. I'm going to try to keep dust out of this case by repurposing the standard cover. It just needs to be trimmed down to the correct size. I mentioned a failsafe in case my pump stops working, and that's going to be this signal wire that ties into a fan header on the motherboard. I'll just have to set this up in my BIOS so the computer automatically shuts down if it doesn't see a healthy signal coming from the pump. Right now I'm just cutting the wires down to their correct length, and this USB cable is going to talk to our Aqua computer chip. It's a shielded cable, so I'm just going to have to solder a new ground connector to the end of the wire that I trimmed. And then we just have to make the connectors for the case power button. It's never quite as easy as you want it to be to work all the air out of the case, but I just had to settle into a pattern of refilling the reservoir and tipping the case back and forth. And then eventually you get to this point where you have enough water that the pump is primed. And then the placement of my reservoir helped collect a lot of air as the loop continued to circulate. Thank goodness I had these guys left over from my old computer as well. You always want to install the most expensive components last. So how does this thing actually run? Well, starting out at idle, our temps are in the upper 30s, and for reference, my shop has a mini split that keeps things very stable at 75 degrees F or 24 degrees C. First up we have Cinebench, which is going to stress the CPU, and it's handling this very well. After 15 minutes, the radiator fans are still sitting at idle, and our water temp has only gone up a few degrees. Now onto Furmark, which is going to stress the GPU. After 20 minutes, we're stabilized with the fans at 900 RPM, which is still very quiet. And now the worst case test, with both Cinebench and Furmark running at the same time. Just a little bit faster on our fan speeds, but we still have plenty of headroom, and I'm curious to see how this design is going to handle way more power-hungry components in the future.
Walk backwards a little bit, more towards like the resin printer. Whenever you're ready.
Ooh,
What do you guys think?
that's super cool. Yeah. Yeah, that looks really good. Ooh, I like that. That looks good. Can I touch it? Ooh. No bubbles in your flow indicator.
Yeah, that's true. That was the big one from last time.
Looks really good. I love it. So what kind of games are we gonna play?